Right, so technically you've learned everything new inside this module already. All what we're going to do now is do another example where we also talk about type 1 and type 2 error in context of a problem. So just as a warning, this video is a little bit longer because we're working a very long, full example here. So reading it closely, let's pull out important information with example 4. So it says in 2012, it was reported that 35.7% of U.S. adults are considered obese. Now first notice of that sentence, there's nothing about a sample being taken. So if I'm thinking anything, I think that this would be my value of P, of this 35.7%. We would like to determine if the proportion of adults in Nebraska that are considered obese is significantly less than this. What I'm reading there, I'm reading my goal. I'm going to be reading my alternative hypothesis right there. So we took a random sample of 900 Nebraskans. So we have our N and got the following results. So here's our pie chart. And so what we can see is of our 900 people, 304 of them were considered obese and 596 were not. And we're also given the percentages. So this is going to help me find my P hat as well. So if P hat is going to be those that are considered obese, my P hat is going to be based upon this yes idea. So P hat is 304 out of 900. Or in decimal form, it's going to be this 33.78 just in decimal form. Okay, now we can actually get to the problems. So who is the population of interest? So who is the group that we're interested in studying? Think about it for a moment because sometimes we do actually get this one wrong. Who are we studying? We're looking at adults in Nebraska. That's our goal. That's who we're looking at. So we're just looking at adults in Nebraska. We're going to compare them to the entire United States, but we're only interested in looking at adults in Nebraska. So would we consider the sample to be representative if our random sample came from cardiac units patients at Nebraska hospitals? So what do you think? I hope that you would think no. I believe I could say that people who are cardiac patients tend to be heavier. Again, I'm not saying they all are, but tend to be heavier. So I think it would be a biased sample. So does that idea make sense? We still want to be thinking about how our sample is being selected, even as we keep moving out of the module we first talked about that. Every time we see a sample, we want to be critical and ask ourselves where it came from. But it says they just took a random sample of 900 Nebraskans. It doesn't say they did the cardiac patients thing, but if they did, I wouldn't consider that to be representative. Now getting to the newer stuff inside this module. What are the hypotheses? So I'm asking you to come up with our null and our alternative hypothesis. Remember the alternative, we kind of labeled something up here. This less than was going to help us with our alternatives. So we want to see if P is less than something. Less than what? Well, this is that 35.7% that we're referring to. So it's going to be our 0.357. Then remember, the null hypothesis has no choice. Always the same symbol. Always the same number. Always an equal sign. Now we're going to relate this back to what we learned in the previous video about type 1 and type 2 errors. So what would a type 1 error mean in the context of the problem? Well, let's first go back and look at what a type 1 error was. So it's when we reject the null hypothesis, or in a sense, we believe the alternative hypothesis, when the null hypothesis is actually true. So that means that if we reject the null, instead we're going to believe that less than 35.7% of Nebraskans of our adults in Nebraska are obese, when in fact it isn't less than that. So that's what we would believe. But the truth then is it actually isn't less. So basically we think Nebraska is maybe slightly healthier than the rest of the United States, when in fact they're really not. Now what a type 2 error would mean, so again going back to our definition, is when we do not reject the null, but the null is actually false. So if we don't reject the null, we are going to believe the percent of Nebraska adults that are obese is not less than our 35.7%. When it really is less than. So that's what our two errors would look like here in the context of this problem. Now what we want to talk about next is, well, what kind of consequences could happen for these? Because our next part is to figure out which error do we think is worse. So let's think about what would it mean, or what kind of consequences could happen for each of those. So if I think about what a type 1 error could result in. So a type 1 error, again, is when we believe that it was less than 35.7%. So if we think Nebraska is healthier than the rest of the United States, something we might do is we might put some money into replicating some programs that they have, because we think they're working. Because we think they help. But it's an error here, so we think that those programs are helping, but they're actually not. What would a type 2 error look like? Well, we might be doing exactly the opposite. We might pull money from those Nebraska programs that we believe aren't helping. Right, because we don't think that they're doing any better. But they do help. Right, so that's kind of the problem with that. We're pulling money from programs that were actually working. So if you look at those two, could you figure out which one is worse? Now, you may have a different decision than me, and that's perfectly fine. You don't have to agree with me on this. When I look at those two, since I don't know maybe as much about these programs directly, I know exactly how much money we're talking about, to me they seem about the same. So for that reason, I would use that 5% significance level that we talked about at the end of the last video. So since I think they're about the same, I would use 5%. If you thought one of the two was worse, you could be using a different significance level than me, and that would be okay here. All right, finally, our last step is to do the hypothesis test. Keep in mind that we already have a lot of what we need here on the previous page. We already have our hypotheses, and I'm going to recopy those on the back. We have our sample size. We have our p-hat. So I'm going to be using a lot of these numbers that you're already seeing here as we do the problem. Alright, so our first step again is just writing out those hypotheses. I'm not changing them. It's exactly what we just had here in part C. So I'm just going to recopy them down here. For our second step, we have that decision rule, which is now going to include our significance level that we chose above. So I am going to reject the null hypothesis and instead believe the alternative hypothesis if my p-value or probability is less than whatever alpha I chose up here, which I chose 0.05. Right, step 3 is sort of when we're on our formula sheet, so it starts with conditions. Now we talked about before that we could have maybe accidentally done our random sample at cardiac patients, but it says here now we're going to assume that they didn't do that and that it is representative. So again, we're kind of assuming that we're doing it okay. Next, we need our n times our p0. So our n was the 900, and that p0 is going to be that 0.357. Which turns out to be 321.3. So basically, if Nebraska was no different than the rest of the United States, we would have expected about 321 people in our sample to be obese. And then the n times 1 minus p0 gets us 578.7. And both of those numbers are at least 10. Next, for step 3, I need my test statistic. So let's go back and look at that formula, which is on page 4 of your handout. So here's our formula. So we have our p-hat from that pie chart, so that 0.3378 number. We have our p0, which is our 0.357, and we have our n of 900. I'm going to carry a few more decimals with our p-hat, though, as we move forward. So if I carry out my p-hat a little bit more, and I mainly recommend doing this when you're doing like homework and stuff, that way you don't have rounding done too early. I was carrying a few more decimals here with that. So then our z is going to be that 0.337778 minus our p0, which is at 0.357. And on the bottom we have that square root of our p0 times 1 minus p0. over our n, which again was that 900. Showing a little bit of an in-between step here so that you can double check your math. So the numerator should be a negative 0.019222. The square root on the bottom should be 0.015970, which then finally doing the division should give you a z of about negative 1.20. Right, next in step 4, we're doing our p-value calculation. So I'm going to draw my picture. Remember, now we're drawing that picture based upon z. Z is always centered at 0. And it's always the same scale on the bottom because we're talking number of standard deviations away. Now we take our z, that negative 1.2, put that on our picture about where it belongs. And then we have to ask ourselves if it's a one-tailed or two-tailed test. So that's where we go back and look at that alternative hypothesis. I'm only looking in one direction, so it's one-tailed. And the fact that it's less than, so it's less than what we're doing. And again, mine are kind of like points the way you want to shade. So we're going to shade to the left of the negative 1.2. So there's what our picture would look like. So now we're going to get ready to go to the table. Since we are shaded left, I get to go straight to my table, look up the negative 1.20, and what I find there will be my probability or p-value, because again, it's shaded left. So we should find in our table the 0.1151. At this point, all of your math is done. Now what we're going to do is we have a p-value. Let's go back to step 2. Is that p-value less than 0.05? Or whatever significance level you chose? No. So since it's not less than, we will not reject the null hypothesis, and we will not believe the alternative hypothesis. This is our first example where we're actually not rejecting. So let's again talk through how does that really change my interpretation then. So I'm first going to start with my significance level, just as I did before. So my alpha is 0.05. Remember, our next choice is deciding if it is or is not statistically significant. And so if you go back to page 4 of your handout, this is where we talked about we choose there is statistically significant if we reject the null hypothesis, and we say that it is not statistically significant if we do not reject the null hypothesis. So since we did not reject the null, I'm going to choose that there isn't statistically significant evidence. So there is not. So nice, easy, remember that this not kind of just comes right down here as well. So there is not statistically significant evidence. To support. Remember, our last thing is that alternative hypothesis, but in words. So there's not evidence to support that less than the 35.7% of Nebraska adults are obese. A couple things just to kind of make connections with things here. So first, remember that there are 3 options for an alternative hypothesis. Remember, so we talked about that there was a not equal to option, a less than option, and a greater than option. So the 3 examples that we have gone through have intentionally been one of each, so you can see how that works. We first did an example with a greater than sign. We then did another example, example 3 here, with a not equal to sign. And then our very last example here had a less than sign. So again, all that really changes is how you're shading the picture. Right, with the less than sign, we're shaded left. With the greater than sign, we're shaded right. And then finally, when you have that not equal to, that's the only time we have to worry about having both sides shaded. Now, the two-tailed one can be a little bit harder for some students. So if you notice below in the Canvas module, there's another example, and that one's doing another example of a two-tailed one, just because I know usually it's nice to see a second example of that. Finally, with our last example, we could use StatCrunch to verify that we've done calculations correctly. Remember, here's sort of our directions that we're going to follow as I bring up StatCrunch. So I just need to bring up a blank screen, and then if I go to that Stat, Proportions, 1 sample, with Summary. So here's where we're going to use our 2 values that created p hat. So we had 304 out of the 900 that were obese. Our null hypothesis had the value of 0.357 in there, and our alternative hypothesis was that less than sign. So then if I hit compute, looking at it more closely and kind of relating this to some of the values that we saw when we did this. So first, notice that the hypotheses match what we did there in step 1. It also calculates our value of p hat, so that 0.33778 number that we carried. This thing labeled as that standard error, again, is like our standard deviation, so our 0.015970 that I had down here on the bottom. This negative 1.2 is what our z statistic was. Now the p-value might not quite be perfect, simply because it had more decimals that it could use for its z, but it's pretty close. So our 0.1144 compared to our 0.1151. So this is a nice way of being able to check to make sure you did things correctly. Of course, keep in mind, again, that you still have to be able to do it by hand because you're not going to have StatCrunch access when you're taking your quizzes and tests on Canvas. So that wraps up this module for hypothesis testing for a proportion. Again, there's another example below that does another two-tailed hypothesis test if you would like to see another one.